When you see that distinctive yellow paint on a construction site, you're looking at more than just heavy machinery. You're witnessing the legacy of a company that literally built the modern world. Caterpillar didn't just make tractors. They revolutionized how humans move Earth, construct cities, and power industrial civilization. But this empire started with one man's vision in a New Hampshire sawmill, and the journey from there to global dominance is anything but ordinary. It was the 1860s, and Benjamin Holt was working in his family's sawmill in New Hampshire, watching his father William cut timber the same way it had been done for generations. But Benjamin saw something different. He saw California's gold rush creating opportunities that traditional methods couldn't handle. In 1883, after the death of his parents, Benjamin made a decision that would change industrial history forever. He packed up and headed west to California. California wasn't just about gold, it was about scale. Wheat fields ran for miles, far beyond anything farmers back east knew. After settling in Stockton, Benjamin and his brother Charles launched the Stockton Wheel Company, and Benjamin quickly shifted toward larger ideas in traction and power. Around the shops he was known as Uncle Ben, the mechanic inventor who could visualize complex solutions without ever putting pencil to paper. The real breakthrough came when Uncle Ben realized that California's rich, soft soil could be a curse for heavy machinery. Steam tractors, often weighing over 10,000 pounds, would sink into the ground, becoming useless exactly when farmers needed them most. Traditional wheels simply couldn't distribute weight effectively across unstable terrain. In 1904, everything changed. Ben's team developed the first practical track-type tractor, replacing wheels with continuous tracks that spread the machine's massive weight across a much larger surface area. The name Caterpillar came a year later in 1905, when a company photographer remarked that the machine crawled like a caterpillar. Holt liked the comparison, and by 1908 the company had officially adopted it as a brand. But the real test came during World War I. Military commanders discovered that these track machines could accomplish the impossible, hauling heavy artillery through mud that stopped every other vehicle. From 1914 to 1918, Caterpillar tractors became essential military equipment, proving that tracks weren't just useful for farming, but for any situation where mobility meant survival. Meanwhile, C.L. Best was building his own empire with a completely different approach. Best focused on lighter, wheeled tractors that could move faster between job sites. When Congress passed the Federal Highway Act in 1921, allocating massive funding for road construction, Best's machines were perfectly positioned for the infrastructure boom. The competition between Holt and Best drove both companies to innovate, but it also created expensive patent battles that drained resources from both sides. When Ben died in 1920, bankers took control of Holt Manufacturing and quickly realized that competition was destroying more value than it created. The solution was inevitable. In 1925, Holt Manufacturing and C.L. Best Gas Traction Company merged to create Caterpillar Tractor Company. Ironically, the man who would lead this new company to global dominance was C.L. Best himself, Uncle Ben's former rival. The newly formed Caterpillar Tractor Company moved fast to establish its identity. The first priority was standardization. Instead of offering dozens of different models, Caterpillar focused on a smaller number of machines that could be manufactured efficiently and supported anywhere in the world. This wasn't just about production efficiency. Caterpillar was building something unprecedented, a global service network that could keep machines running in the most remote locations on Earth. By 1928, the company had 82 dealers in the United States and 58 internationally, each required to maintain specific parts inventories and trained technicians. Then came 1931, a year that would define Caterpillar's visual and technological identity forever. C.L. Best made two decisions that seemed unrelated but were both brilliant. First, he painted every Caterpillar machine in highway yellow, a color chosen specifically for maximum visibility and psychological impact on job sites. The second decision was far more revolutionary. Caterpillar introduced its first diesel engines, starting with the Diesel 60 in 1931. This engine was the production version of the D17000 prototype that engineers had been developing and testing since 1930. Why diesel? The answer lay in understanding how track machines actually worked. Unlike wheeled tractors that needed to travel at highway speeds between fields, track-type tractors operated at constant, relatively low speeds while pushing enormous loads. Diesel engines produced dramatically more torque at low RPMs compared to gasoline engines, making them perfect for this type of work. Plus, diesel fuel cost less and delivered superior fuel economy, crucial advantages during the Great Depression. The timing couldn't have been better. By 1932, Caterpillar was facing its first major crisis as sales collapsed from $52 million to just $13 million. But the superior efficiency and reliability of diesel engines gave Caterpillar a competitive edge that would prove decisive as the economy recovered. World War II transformed everything. Suddenly, the military needed bulldozers to build airfields across the Pacific, clear landing zones in Europe, and construct supply roads in every theater of operation. Caterpillar's global dealer network became a strategic military asset. They could deliver parts and service to remote battlefields, where competitors couldn't even locate their equipment. This war validated Caterpillar's entire business philosophy. When a bulldozer broke down on a Pacific island, there was no time to ship it back to California for repairs. Caterpillar's standardized parts and trained dealer mechanics could perform major overhauls under combat conditions, keeping Allied forces mobile when equipment failure could mean the difference between victory and defeat. By 1947, Caterpillar was introducing more sophisticated technology like the D318 inline-6 engine that powered the D6-8U and 9U tractors. These engines incorporated hard-won lessons from wartime operation, with modular designs that allowed field mechanics to replace major components without removing the entire engine from the machine. The post-war infrastructure boom created demand unlike anything the construction industry had ever seen. The interstate highway system alone required moving billions of cubic yards of earth to create 41,000 miles of divided highways. Caterpillar responded by scaling up everything. Dozers, scrapers, and graders all grew larger and more powerful to handle projects that dwarfed anything from the pre-war era. The D17000 V8, originally introduced in 1938 but widely deployed after the war, became the foundation of Caterpillar's stationary power business. This engine powered generators at remote construction sites, mining operations, and industrial facilities where electrical grids couldn't reach. Its ability to run continuously for thousands of hours with minimal maintenance established Caterpillar's reputation far beyond mobile equipment. The 1960s brought aggressive expansion into industrial markets that had previously been dominated by other manufacturers. Oil companies needed reliable engines for pipeline compressors and drilling rigs. Marine operators required power for tugboats and offshore platforms. Mining companies demanded engines that could operate continuously in harsh environments. Caterpillar's entry into modern on-highway trucking came with the introduction of the 1693 inline-6 in the mid-1960s, a turning point for their truck engine business. This engine was specifically engineered for over-the-road applications, with higher operating speeds and different duty cycles than traditional off-road engines, but it maintained the durability characteristics that made Caterpillar engines legendary. 1973 marked a watershed moment with the introduction of the 3406 inline-6, which became the backbone of North American trucking, often running 500,000 miles between majors when maintained. Its modular design kept overhauls economical even after long service. The 3408 V8, launched later in the 70s, targeted applications requiring maximum power in compact spaces. This engine found homes in marine vessels, specialized equipment, and stationary generators where space constraints made larger inline engines impractical. Here's the recap of how the roles split in the field. The 1693 inline-6 was the bridge into true highway duty, higher revs, and long daily cycles. The 3406 became the standard because it matched frame packaging, pulled hard from low to mid RPM, and was rebuildable almost anywhere. The 3408 V8 solved a different problem. Heavy power in tight spaces for marine, specialty vocational, and stationary sets where an inline-six simply would not fit. Same dealer ecosystem, different use cases. The 3412 V12, developed during the mid-80s, represented the pinnacle of Caterpillar's large displacement technology. Designed for ultra-class mining trucks and massive industrial power generation, this engine could produce over 1,400 horsepower while maintaining the reliability that industrial customers demanded. The 80s brought fundamental strategic changes. Caterpillar's 1981 acquisition of Solar Turbines added industrial gas turbines to the company's power portfolio. Solar's turbines were perfect for natural gas pipeline compression and industrial power generation, complementing diesel engines while providing exposure to different fuel technologies. This acquisition reflected Caterpillar's recognition that industrial power would require multiple technologies. While diesel remained dominant for mobile applications, gas turbines offered advantages for stationary power generation, especially in locations with abundant natural gas. The 3500 series, launched in 1982, represented a completely new approach to industrial engine design. The 3512 and 3516 engines were engineered specifically for continuous duty applications. Running 24 hours a day, 365 days a year in power generation, and marine propulsion. This required exceptional attention to cooling systems, lubrication, and component durability that differed significantly from mobile applications. 2 years later, the 3600 series addressed a different market need. While the 3500 series covered oil field drilling, well service, and many generator sets, the 3600 series was developed as a medium-speed platform for large continuous operations, such as electric power generation, gas compression, and main marine propulsion. These engines are built for steady-state duty at roughly 720 to 1,000 RPM, with infrequent starts, tight temperature control, and long overhaul intervals. The 3500 series was optimized for constant speed work. Think generator sets, marine propulsion with steady loads, and pump duty that values fuel rate and uptime at 1,200 to 1,800 RPM. The 3600 series stepped up in size and torque at slower engine speeds, better for variable or shocky loads in drilling, large pumps, and mining where the throttle is rarely steady. Service models diverged too. The 3500 rewarded interval discipline and parts commonality across big fleets. The 3600 demanded fewer startups, meticulous cooling, and careful load steps to live its best life. The D399, which had first appeared in the mid-60s, continued serving heavy industrial applications throughout this era. This engine's longevity demonstrated Caterpillar's philosophy of continuous improvement rather than complete redesign. The basic architecture remained sound, while components were upgraded with new materials and manufacturing techniques. The late 90s brought new challenges from emissions regulations and international competition. Caterpillar's 1998 acquisition of Perkins, a British engine manufacturer, provided access to smaller engine technologies and established relationships with equipment manufacturers needing 50 to 200 horsepower engines. The early 2000s marked a technological turning point as EPA emission standards required dramatic reductions in nitrogen oxides and particulate matter. Caterpillar's response was ACERT, Advanced Combustion Emission Reduction Technology, launched in 2003. The C7, first sold in 2003, incorporated ACERT technology from the ground up, with sophisticated electronic controls monitoring dozens of operating parameters and adjusting engine operation in real time. The C9, also introduced in 2003, targeted larger applications with the same advanced technology. The C15 ACERT, launched in 2003, replaced the legendary 3406E in heavy-duty applications while maintaining the durability and rebuild capability that made the 3406 series famous. The C13, introduced in 2004, completed the ACERT lineup for medium-duty applications. ACERT was designed for higher injection precision with multiple events per cycle, tighter air handling with staged turbo setups, and combustion shape to cut NOx in cylinder before exhaust treatment. It worked, but 2007 rules forced bulky aftertreatment in highway chassis. DPF packaging added weight, heat load, and maintenance that line haul operators felt every day. Off-road machines had room and different duty cycles, so the same tech landed cleaner. By 2009, the math said road engines were soaking capital and dealer bandwidth, while construction, mining, marine, and power gen matched CAT's strengths. Exiting highway was not a retreat, it was focus. However, ACERT's complexity created field challenges. The technology performed exceptionally when properly maintained, but required more sophisticated diagnostic equipment and training than previous mechanical engines. Some operators struggled with the transition, creating reliability concerns that would influence future strategy. Caterpillar made two significant moves in 2006, acquiring Progress Rail to expand into locomotive markets and introducing the C32 V12 engine for high-power, compact applications. The 2007 emission standards proved to be a turning point, requiring exhaust aftertreatment systems that added significant complexity and cost. For on-highway applications where weight and space were critical, these systems created substantial challenges. In 2009, Caterpillar made a strategic decision that reshaped its engine business, exiting the North American on-highway truck market to focus on off-road applications where its expertise provided stronger advantages. The same year brought the C175-20 platform for ultra-class haul trucks and large generator sets, capable of producing over 4,000 horsepower. The on-highway exit took effect in 2010, though Caterpillar continued supporting existing engines through dealers. This decision reflected the reality that off-road applications better suited Caterpillar's strengths, which were customers who valued durability over initial cost, and applications where aftertreatment systems could be properly sized without severe weight penalties. The 2011 Bucyrus acquisition for $8.6 billion dramatically expanded Caterpillar's mining equipment portfolio. This acquisition brought expertise in large mining shovels and draglines, establishing Caterpillar as the dominant global mining supplier while creating new opportunities for the company's largest engines. Between 2012 and 2016, Tier 4 final emission standards were implemented across construction, mining, and power generation. Unlike on-highway applications, these markets could accommodate larger aftertreatment systems, validating Caterpillar's strategic focus. The C27 V12, carrying that designation since 2000, continued serving high-power density applications. The C32 V12, introduced in 2006, established itself in marine vessels and oil drilling rigs. The C175-20 platform represented the pinnacle of Caterpillar's technology for ultra-class mining and power generation applications. Since 2017, Caterpillar has focused on services revenue and connected technology. Real-time monitoring of engine performance enables predictive maintenance and optimization based on actual usage patterns rather than predetermined schedules. Flagship pairings make it real. C175-20 powers the 797F ultra-class haul truck and large gensets that carry remote sites. The 3516 remains a staple in marine propulsion and big standby plants because parts, service knowledge, and predictable intervals keep downtime priced out. On fuels, today's C-Series and 3500 families can run on HVO where available, and gas variants plus solar microgrids cover sites that want lower carbon with fast start and strong part load behavior. The company is exploring alternative fuels while maintaining diesel expertise. Solar Turbines continues developing gas turbine solutions, while Caterpillar engines are being adapted for natural gas, hydrogen, and biofuels. Today's portfolio spans from compact Perkins engines to massive C175 power plants. The 3500 series continues serving marine, oil and gas, and power generation markets. C-Series engines power construction and mining equipment globally, incorporating advanced electronics while maintaining the durability that built Caterpillar's reputation. The global service network, established nearly a century ago, remains the key advantage in markets where downtime costs exceed initial equipment investment.